Wind is an unpredictable yet tremendous power. It can be destructive at times, but if used properly, it is a massive energy source. Mongolia's main source of electric power is coal. Rapid development and urbanization is drastically increasing energy demand. The country's energy demand is expected to double within the next 15 to 20 years. Utilization of renewable energy is necessary to meet this growing demand in a sustainable way. The government of Mongolia has set a goal to have renewable energy reach 20 to 25% of the total energy mix by 2020. Newcom started its first wind resource assessment in 2004 by acquiring over 12,000 hectares of land in Surgalemsum of Tov province.
The country's very first large power plant built for the Ulaanbaatar area was powered by a coal mine in Nalakh. Coincidentally, Nalakh today is also the connection point for delivering clean power produced at the SALKHIT wind farm to the central system at Ulaanbaatar. The SALKHIT wind farm consists of 28 kilometers of 110 kilovolt double-circuit overhead transmission lines and 31 wind turbine generators, each with a unit capacity of 1.6 megawatts. The plant will supply 168 gigawatt-hours of clean energy per year to the central energy system. In the process, it reduces greenhouse gas emissions equal to 178,000 tons of carbon dioxide, saves 1.6 million tons of fresh water, and avoids the use of 122,000 tons of raw coal each year, contributing to the efforts of global climate change mitigation and air pollution reduction in Ulaanbaatar city.
Opposite, you can see in the distance there the crane. It's a concrete batching plant. Yeah. Basically, to the left of that, up the hill is the other end of the string.
Yes, I noticed that.
Substation's in the middle.
They're down while we are digging there, so deep in the area.
We're just taking some gravel from there for the road, and then we'll backfill that with soil. It's just a borrow pit to get material for the road.
Yeah.
To save, we didn't want to cut it in the hill and cut it very far because you just damage the ground. So
yeah, sure.
We're trying to avoid driving anywhere where there's no road.
Yeah.
This project first began when our chairman, Mr. Boldbatar, saw a wind resource map of Mongolia. I had been working at the Renewable Energy Corporation for over 10 years. One day, Newcom directors came to us asking where would be a good location to build a wind farm in Mongolia, and if there were any sites near Ulaanbaatar. To build a wind farm, you need to conduct detailed resource assessments first, with met masts of at least 50 meters tall and high-precision instruments that meet international standards. We did not have such equipment in Mongolia at that time, which was a barrier. But this wasn't an issue for Newcom. They said they can handle this and invited me to work with them. That's how I first joined Newcom in 2004. After 6 to 7 years of wind measurement and analyses, we selected the current area near the SALKHIT mountain to build a 50-megawatt wind farm. We realized a few things. First of all, that global warming is real and we have to do something about it. Secondly, our country has enormous wind resources waiting to be tapped. We understood that this project is achievable and should move forward. Of course, to reach this decision, there was a lot of debate and discussions within the company. At the beginning, most people didn't support this project, but at the end, everybody realized its importance. That's how the project started.
I think we started looking at this project in 2006, about the time that EBRD started looking at Mongolia as a country of operation. And it was very clear at the time that this was a very innovative and trailblazing kind of project that if we could help make happen would open the doors for many, many more projects of this kind in Mongolia.
The bigger the wind turbine, the more beautiful it looks. The taller it is, the better it can capture stronger wind, producing more energy. The wind turbine generator nacelle and blades are made from carbon fibre and epoxy composites, ensuring maximum durability, light weight and flexibility for stable operation and resilience against the elements. The blades are 40 metres long, with a weight of 6.2 tonnes each. The length of a blade is nearly half a football field. The hub measures 3.2 metres in diameter and weighs 23 tonnes. The nacelle is 8.8 metres in length, 3.8 metres in height, and 3.6 metres in width, and weighs 57 tonnes. The tower is 80 metres tall, weighing 125 tonnes, and consists of 3 pieces. Wind data loggers are installed on top of the turbines. The computer analyzes this data and automatically directs the turbines into prevailing wind directions. The turbine goes into operation at a wind speed of 3 meters per second and automatically engages its brakes when the wind speed exceeds 25 meters per second to ensure safe operations. At full capacity, the rotor speed of 18 RPM is increased via the gearbox to 1915 RPM through the generator to produce electricity. The GE 1.6 megawatt series wind turbines are tested and proven machines, with installation of more than 20,000 units throughout the world. The SALKHIT wind farm construction started with preparation of 33 kilometers of access roads that connect the turbines with the substation. On site are a project team office, workers' camp and canteen. A temporary concrete batching plant is also set up. Preparing the reinforcing bars and wind turbine foundation earthworks are to be done next. Assembly of the main crane, the first of its kind in Mongolia, is just complete. Its boom measures 90 meters in length and has a lift capacity of 650 tons. Mongolian engineers are successfully learning and being introduced to new technologies and know-how throughout the project. The success of any large project development undoubtedly depends greatly on the legal and regulatory environment. For Mongolia, government's policy and regulatory framework for renewable energy sector development was set up relatively late and was not until 2005 when the parliament approved the government's policy on renewable energy. One of the most important documents for developing and operating a wind farm is the PPA, the Power Purchase Agreement. As SALKHIT's PPA was the very first such agreement in Mongolia, it was a new task for us all. Newcom and the Energy Regulatory Committee team spent a great amount of time negotiating and finalising the SALKHIT PPA. PPAs have been used in many countries, and we use them as a reference for international best practices, while also making sure it's suited for Mongolian conditions. There was a lot of back and forth, a lot of negotiation, and we faced many challenges, including ensuring all the translations were done properly. We had technical inputs from the Nationwide Renewable Energy Centre. And in all, it took us about 2 years to finally complete the whole process. Discussion of the draft renewable energy law started at the end of 2006. I was head of this law's working group at the time and faced various challenges. The main issue we identified was that the law has to set the tariffs if it were to be implemented. We visited Germany and the Netherlands to learn from their experiences and met with project developers. As a result, we were able to include tariff pricing in the law. The tariff has to be in place in order to attract foreign investors and develop the sector. This was a hotly debated issue at the time, and we faced a lot of opposition. But in the end, we managed to get this landmark law passed. There were two main issues during the PPA negotiations. Firstly, foreign and local investors were jointly involved in this project. Thus, finding the right balance between the interests of the private investors and the interests of our own energy system was a challenge. We spent a lot of time on this issue. After extensive research, we arrived at the tariff rate of 9.5 cents per kilowatt hour. We compared this to tariffs of the other countries. For example, I believe Spain's tariff is 17 cents per kilowatt hour, while Denmark's is 24 cents. Compared to these rates, ours is not considered high. The other issue we had to keep in mind was that this was the first time private and foreign investors entered the energy sector in our history. So it was important to support and encourage investors through the legal framework by setting the tariff. The PPA was the foundation for subsequent steps in the project development. This was done as a result of joint efforts and collaboration between the private sector and the government.
The EBRD played a very active and engaged role on this project. We did something quite unusual, but we did that because we recognized that we had in Newcom a very strong, able sponsor, but that one that needed a partner to help them get the framework and the things needed to get this project off the ground actively. And so I think we were very, very crucial in making this project happen.
A total of more than 600 heavy-duty machines were used during the transportation of the wind turbines and site earthworks. The turbine components had to be trucked on unpaved roads to bring them from the Chinese border to the wind farm site. The first convoy of wind turbine blades is ready to depart GE's factory in Shenyang, China. It will reach the border city of Erlian after travelling 2,000 kilometres for 24 hours non-stop. Border point at Zamin Ud. The convoy has gone through customs and arrived at the Zamin Ud Free Trade Zone. The Chinese drivers, who are accustomed to high-quality highways, have no idea what challenges await them in Mongolia.
Let's go. Okay.
The convoy hasn't even gone 1 kilometre before it got stuck in the sand. The distance from Zamin Ud to SALKHIT is 540 kilometres. Due to the poor road conditions, the convoy had to travel at 10 to 15 kilometres per hour to ensure safe shipment and no damage to the cargo. With such speeds, it took 3 or 4 days to finally reach the destination. "100 kilometers into the journey, another unexpected problem arose.
There's a 2.1 meter sling with the capacity of 20 tons, and it's being worn out. Yeah, it's rubbing against the blade.
The blades were secured onto the trailers with thick straps. Due to heavy vibrations caused by the poor road conditions, the crew noticed that the straps were badly damaged and could break any time. Continuing with the journey would likely damage the blades. What worked on paved roads elsewhere clearly was not working here. After a long discussion, the crew decided to bring in a crane and new straps. Another half-day passed before the blades were secured in place and ready for the journey. The sun has set, and it is now far into the night. Meanwhile, at the wind farm site, wind turbine foundation works have begun. The concrete is poured and samples of the mixtures are taken and tested in the laboratory to ensure quality. It typically takes 21 to 28 days for the concrete to reach the required strength. By the time the last foundation base is poured, the first ones are already cured. Skur Energy is the owner's engineer for this project.
So we're at a point where we're 4 months into construction. I'd say the civil works and the earthworks are well underway. The earthworks almost finished, and the civil works for the foundations are about a third of the way done. A project like this, you could probably break it down into 3 main components. One's the civil works, the erections, and the substation. So now we're on a point where we're just about to start the erections. We're just out of a monthly progress meeting with everyone. Like with any big project, there's a big handover where the turbine manufacturer is handing the components over to the transportation company. So I'd say some of the issues we're experiencing right now have to do with that interface between the turbine manufacturer and the transportation companies, but it's quite normal for a project like this, so we're working through it. And next couple of weeks we're looking at the first couple of turbine erections, and then within the next month we'll start the actual substation building and move forward with that.
The first batch of wind turbine component transport was a big lesson learnt for the team. The next shipment was to be delivered by Mongolian drivers. This time, they transported larger and heavier components, including generators, nacelles and towers. Mongolian drivers took over the cargo at Urlian Hot and started their journey back to Mongolia. Although the Gobi Desert does not have deep forest or high hills to block the way, it has extremely loose and sandy soil, making any transportation highly challenging, especially for heavy shipments. But this time, the crew was well prepared with enough people, equipment and tools. Throughout the 200-kilometer journey from the state border to Dornogobi province, the trucks had to be pulled from sand by heavy machinery numerous times. There were fewer challenges than expected, but the road was getting softer and sandier the more they drove. Halfway into the journey, the first truck carrying a section of the turbine tower got stuck in the sand. Despite all their efforts, the experienced drivers and crew were helpless against nature. The next morning, the crew called in special metal plates and tractors to help with the transport. It took the team 2 days of struggles to finally get out of the sands. Everyone was exhausted, but happy. The convoy continued driving with the help of the heavy machinery and metal plates. Finally, they reached Chire and the beginning of the paved road heading towards the wind farm site. Does anyone in the world transport this kind of equipment on roads like ours? It's definitely the first time in Mongolia. These heavy trailers are built for paved roads, but we're driving them through dirt. I guess none of the equipment could fit onto rail wagons. But nonetheless, I'm quite happy to be contributing to a nice project like this. Seven to 8 trucks are required to bring in the complete package of one wind turbine. 3 to 4 packages are transported in one journey. This way, transportation of the total 31 wind turbines continued throughout summer and autumn. The foundation building is now ready, and the reinforced concrete will be built next. The foundation that holds this huge structure in place requires approximately 50 tons of rebar and 800 tons of concrete. The whole foundation, from start to finish, takes around 1 month before it is ready for tower installation. Substation construction works have begun. This is the first large structure built in Mongolia with thermoblock, a locally produced insulating concrete form that is a very environmentally friendly and energy-efficient building technology. This eco-building is cost-efficient, has minimal heat loss, and is very suitable for Mongolia's harsh climate. The 31 wind turbines are connected to the substation via underground electric and fiber optic cables. Preparation works are complete, and now it is time for erecting the wind turbines, a moment that everyone has been waiting for. The team gathered at the project site to witness the first turbine erection with great excitement, curiosity, and anticipation.
We have a JSC8. This is our standard job safety environment.
Safety is of utmost importance on the project site.
We all signed, and please abide by the safety rules. This is the safe zone, this is the danger zone. We all coordinate it, it's all controlled, and we'll all work safely. Okay? So enjoy your day, and please God, it all goes successfully. Thank you.
This is the moment we've waited for, some for months and some for years. Mongolia's first turbine of the first wind farm is going up. We've been here from 7 a.m. this morning. Now it's 4:20 p.m. The erection crew has finished the preparations and is ready to lift. There are 12 people working in the crew. 5 of them are Mongolian engineers, learning and lifting their first turbine. Turbine erection works are very much dependent on weather and wind conditions. Early mornings and late nights are usually the most suitable times, as the wind speeds are lower. Today, luckily, was a nice, calm day. The erection crew is highly organized and skilled. Installation of the blades is especially challenging and requires great care. With many large and heavy components placed close together, any misstep can damage the parts.
Hold that! Hold it! Oh hell, there's 2 marks here, which one are we having?
That one's at left.
That one?
Yeah.
There are 54 bolts on each blade. If any one of them gets damaged, the blade may need to be sent back to the factory. Thus, everyone has to work under extremely careful coordination and professional teamwork under one command.
Too right. Hold that now. Hold stop.
Up goes the first ever wind turbine in the country. "14 more turbines have been erected since the first erection this autumn.
SALKHIT represents a lot of firsts for Mongolia. The first private investment in public infrastructure, the first private power project, the first wind farm. But also SALKHIT represents what is so important in Mongolia, which is the ability to use all of its resources in an efficient way and sustainable way for the future of the economy. And I think SALKHIT is a very good counterbalance to what we hear about Mongolia all the time, which is about the big mining projects. People forget that one of the other very, very vast resources it has is wind. So SALKHIT, in a way, is leading the way for the development of another resource that Mongolia has.
Our number one goal was quality. Nobody here has any experience building a wind farm of this size. Throughout the project, particularly during the tendering and construction stages, ensuring the best quality was our priority. That is why we chose the General Electric turbines. These turbines are tested, highly efficient, and built for the harsh conditions we have in Mongolia. We also selected internationally reputable contractors and consultants to build and design the project.
General Electric Company.
SALKHIT Wind Farm is GE's first large project in Mongolia. We supplied the first large-scale wind turbines connected to the central grid, and we are very proud of this. Leighton LLC was the main contractor for the project construction works, involving 18 local construction and engineering companies as subcontractors. The project employed more than 500 staff during the peak period, of which 94% were Mongolians. Winter arrives, and SALKHIT is covered in snow. The team is working hard in 2 shifts, day and night, to complete many tasks before the extremely cold winter sets in. The substation building is now complete, and the electrical equipment installation works have commenced. Workers' camp, 5:26 a.m. After breakfast, The erection crew is going over the daily health and safety instructions and getting ready to start the day's planned works.
Yeah, we have to finish at 28, and then we'll see how we go. But on the safety side of things, just watch your speed, obviously, and just be careful when you're walking around in the tower sections.
The weather forecast says today will be a clear and calm day. The temperature outside is minus 25 degrees centigrade. Well, now we're assembling the rotor. Almost finished installing the last blade. After this, it's 6 hours of talking. Installation of towers requires 138 bolts for the bottom section, 120 bolts for the middle section, 100 bolts for the top section, plus 64 bolts for the nacelle, all to be bolted and torqued twice each. What's going on now? We're now setting out the bolts, getting ready for the next tower section.
Eggy, Ulmer, all the lads in the tower, brilliant. I think they could build it themselves now, definitely.
Installing these huge structures on top of the mountains is certainly risky. Any errors could result in serious injury and risk damaging the multi-million-dollar equipment and machinery.
All stop, Wayne, all stop.
The next task is to install the nacelle on top of the tower. The 80-metre-tall tower sways in the wind. The crane operator and the crew managing the guy lines connected to the nacelle play essential roles.
Right, all stop, Wayne. Start creeping down on your ropes, nice and easy for me.
They need to work under exact order from the team on top of the tower guiding the installation.
Yeah, creep down again, Wayne, creep down. Right, creep down on your ropes, Wayne. Nice and slow, nice and slow. Right, Wayne, you can come down on your ropes. Come down on your ropes. All stop, Wayne, all stop. We'll get some bolts in.
Now, the final and most challenging work begins. Connecting the assembled rotor to the nacelle. The 650-ton crane lifts the rotor, while a 200-ton crane lifts the bottom blade to prevent the rotor assembly and blades from touching the ground. Everything has to move under one command. Lifting and moving the enormous and heavy rotor to a precision of millimeters requires great skill and experience by the crane operator. Despite the cold weather, the team is working under tight schedules. The main high-voltage transformers here are some of the most important parts of the substation. One of the main transformers is being installed on its foundation.
second one's good on you.
The erected turbines are handed over to the installation crew to complete internal fit-out and electrical connection works. After completing the commissioning tests, the wind turbines are ready to operate. Harsh, cold winter days have passed, and the site welcomes spring. At the workers' camp, contractors are discussing their work plans.
So, action done, signed off, tests completed, locked out, handed over to GE.
We have trained the team that will be operating the wind farm. This team of Mongolian engineers and technicians had learnt a lot of new things from this project. We were the pioneer for developing a project of this kind, so being the first, no doubt, comes with many challenges. The clean energy team worked hard together and are now leading the way in this sector. General Electric will be working to build the capacity of Newcom's engineers for the next 5 years, ensuring the technology is well adapted to local conditions. Our team has 4 members, 2 from Mongolia and 2 from China. The Chinese team members are here to consult for us temporarily, after which we will continue by ourselves. I've been attending training since I joined GE officially, and I've been working on wind turbines for 3 months now. The construction work has continued through 4 seasons and is now nearing the end, with the last of the 31 turbines ready to be erected. We had 10 riggers who are expats, plus 7 or 8 of us. Together we've worked on these turbines from last year until now, almost a full year, including the winter break. Now it's finally finishing. It's coming up now. Just need to set it right and insert it in, and we'll be done. It's certainly a great feeling, this being the very last piece. Lots of people have come to watch. Okay, the rotor is coming up. Time to get to work.
Your height's good there, matey. Your height's good. Start coming down on your head, pal. Down on your head. You've got about 3 metres to come, mate. 2 metres to come now, mate. 1.5 metres. Metre. Nice and easy now, matey. Nice and easy. Okay, hold your head. Hold your head. Just hoist up for us now, please, Terry. Hoist up, mate.
Just slow to your right a touch, mate. Slow to your right a touch.
Keep it coming like that, pal. Okay, I'll stop now. I'll stop. Ben, just pull on your tagline again, mate. This rotor's gone back round to Mark Blake. So, Mark, release yours a touch, mate. Ben, pull on yours. Other way. Turn the rotor the other way. Hold that. Just jib down for me now, mate. Jib down. Jib down. Ben, pull on your tagline a bit, mate. Keep jibbing down, Terry. Keep jibbing down, pal. Keep it coming, mate. Keep it coming. Keep it coming. All stock now, mate. We'll get some bolts on here. That's all. 31 turbines erected. Thanks, everyone. It's been a pleasure working with you all.
Good work, Barker. Good work, guys. Well done. Top effort. Marcus, that note was 16 mil, not 15. It still went in.
While the erection crew celebrates, final testing is going on in the substation.
Right. Good. Perfect.
За тэрийг 110 км тэрээс залгагдсан гэж болголоо.
The official opening ceremony of the SALKHIT wind farm. This is a historic day for the country's energy sector. For Newcom and Clean Energy employees, it is a big achievement to see the result of many years' work during the 20th anniversary of Newcom Group. We are extremely happy to be opening the SALKHIT wind farm on this beautiful sunny day. The ceremony was attended by the Ministers of Energy and Environment, the company's management, investors and partners, and many other international and national stakeholders. Mongolia's first wind project, the 50 megawatt SALKHIT wind farm, is finally in operation. We had international experts and Mongolian companies working together on this project, but the majority of them were Mongolians. Going forward, we will have Mongolian engineers operate this plant.
I went back again to sign the deal in 2012, and I went to the site. And when I say the site, that's all it was. No road, there was no access to the site, and it was just vast hilltops of nothing but snow. And I have to say, I was completely blown away going back less than 15 months later. It was remarkable that we overcame all those challenges, and now in 2013 we have an operational wind farm in Mongolia.
The success of this project shows everyone that it is possible to develop large-scale wind farms in Mongolia, and that implementing clean and green energy is a viable option. It serves as a model project for all future developments. Now that we have a successful project, we know that we are able to have other renewable energy projects, such as hydro and solar, and eventually produce a substantial portion of our energy from these new sources. Now is the time to really see whether a project like this can continue on successfully. We are facing a lot of responsibility in this sense. On one hand, the construction is finished, but on the other hand, the work has just begun.
Бид салхин
We have made the first step for wind power and hope this will pave the path for many new projects in the future. What started as a distant dream, through years of determination, effort, and collaboration with international partners, has finally become a reality.